everyone, welcome to the SUHNER Repair Shop. Today we're going to talk about the Max 100 drilling spindle and some maintenance on it. Today we're going to talk about the stroke adjustment or flag nut adjustment for our Max drilling units. This is a Max 100 spindle we have here, but this also applies to our Max 40 and Max 200 units. They all adjust similarly. What we're talking about is our flag nut adjustment, or how to adjust the ejection stroke of our tooling, whether it be Cat 50, Cat 40, or HSK. The tools needed today would be a ratchet and socket, would be a little easier, or you can use Allen wrenches. You will need a 10mm open end ratchet, and then wrench, and then you will need some type of linear scale, and again, maybe calipers or measuring device. The first thing we're going to do is disassemble the back of the unit to get to our flag nut. Okay, so now we remove the Deublin coolant union off the back of the unit. We'll set it aside. Of course, you have two 1/2 moon clamps that hold it on. We'll take that off. Now what we'll do is remove this whole back unit here. It's the easiest thing to do. And we've removed our large socket head cap screws here. The next thing is the small alignment pins. You have one on each side. This is what aligns the back housing to the body, to the transmission housing. You can do it without it, but it's a little easier to pull these pins out before you try to pull the whole back plate off. So we'll take a standard M5 socket head cap screw, go into the back of the pin, and then we'll just use pliers or some type of little crowbar, anything, or screwdriver even, just to pull the pins out. You can see we pulled the pin out of the body a little bit. Do the same thing on the second side, and you saw it drop down. And we'll take this whole unit, and it's heavy, slide it out. Be careful not to damage the drawbar. You don't want to damage or nick this. And so that's it. Now we've disassembled the back side. Okay, so now that we've disassembled the back of the unit, we pulled it off. Now you have your flag nut, which is here, and then you have a little small jam nut, and this just keeps the flag nut from moving. One thing I want to point out is this flag nut has changed a little bit in variations over the years. You may have one that looks like this with just two socket head cap screws on it, and of course you see that it's got a cut in it for a clamp. You may have to, of course, screwdriver and pry that out sometimes to get that loose, but that's one design. Another design is this. This is a two-piece design. You have your flag nut here, and then you have a sleeve that goes around this. And the reason that makes it smooth all the way around. There's no slits for sensing. So that's just only for a sensor, not to cause any problems there. The other difference in this one is sometimes you will have a set screw hole. So just make sure that when you look at the flag nuts, just make sure you've loosened everything there to make sure it's free to spin. As you saw, it should be easy to move. So you can use a punch pin. We'll talk about that a little later. There's another way to do this, but when it's on the bench, of course, this is a little easier. So you can use a punch pin to hold this back nut, and jam nut's all it is, or you can use a small set of spanner wrench to hold. So we'll hold that. Then again, we'll need to hold the front of the unit. We'll break that loose. And now you're free to move this. So we'll loosen the Allen screws. And again, these may be a little tight because you don't want it moving. Now the thread on this is 1.5 millimeters. So every revolution is 1.5 millimeter of thread. The ideal ejection stroke is between 1 millimeter and 1.6 millimeters. So again, if you go a full revolution, that is a lot. So again, this shouldn't have to be adjusted from the factory, but if it does, this is how you do it. So again, it's 1.5 millimeter pitch on the threads. You adjust this just like I did, just loosen the Allens here, 10 millimeter wrench. You'll hold it right back here on the drawbar. and then you'll turn this like you want here. Like I said, again, it's very, very limited. We do have a sheet that goes along with this that we can show this. This will be attached to the video. You can see that at the bottom. You can see how this works. The mechanism here, this is our pneumatic system, but what this does is this ejects or push pressure on the drawbar to eject the tool. So the flag nut is actually pressed here, and that's what pushes the springs and opens up the gripper of the unit to eject the tool. And the way this works is here is the cylinder is in the home position, and then this is the eject position. So the distance between the ejection piston and the flag nut determines your ejection stroke. So that's what we're doing by moving the flag nut backwards or forward. That's what changes the stroke of the unit. So what we'll do is we'll put all this back together. Now that we've got this adjusted, we'll put everything back, and then we'll check the ejection on the front of the unit. This is your drawbar. Want to make sure we don't do any damage to the drawbar, especially its octagon shape here. This is what your Deublin coolant union attaches to. All right, we'll slide this up here, align our pins, take a rubber mallet, drive our pins back in, and then we take our M12 socket head cap screws and tighten it back up here. All right, now that we got our plate on, the next thing is we take our Deublin coolant union and we got to fit back on the shaft here. You want to make sure at the end of the drawbar there are no burrs. This will create a lot of headaches to align up in the octagon shape down in the Deublin union. So this will slide right over. You may have to move your the shaft or the spindle of the unit to align the drawbar. The inside here does spin, so you may have to turn it a little by hand and then try it again. That's what you're looking for. You're looking for the union to slide all the way back down on the units, and then your half moon C-clamps go in the groove of the unit. And this holds in the Deublin union and keeps it from coming back out, but allows it to, of course, free spin inside. Okay, now that we have everything back together, we showed you how to do a flag nut adjustment with the back end off. So now we've reassembled everything. Now we need to check our ejection stroke. Now that we made adjustments. So we'll need some type of air valve. Of course, this is on our bench. We'll just use a manual valve, or if it's on the machine, of course, you just do it through the program or through the controls. So you'll need some type of tube holder here. So we'll fully insert our tool, and we'll clamp it. All right, so you can see it's fully clamped. We'll take a measurement in the fully clamped position. And you can see we're around 19 millimeters fully clamped. And now what we'll do is hold. We'll make sure we put pressure and hold on the tool and eject the tool. And you saw it move here. Now we'll measure it again. And you see we're about 20.6 or so millimeters. So therefore, 19 millimeters plus 20 or minus 20.6 millimeters gives us about 1.5, 1.6 millimeters of adjustment, and we're measuring, like I said, the amount of when it's all the way in to when it's all the way out. You want this, typically you want this push or this ejection stroke to be between 1 millimeters and 1.6 millimeters. So that gives a good push. Therefore, it makes the tooling easy to eject in a dirty environment or whatever. You're pushing against the back of the tool to make sure it ejects cleanly. Okay, so now we've checked the ejection of our unit, the ejection stroke. We've checked, we've adjusted the flag for the ejection stroke. Now, the way we did it was take the whole back end of the unit off. Another way to do, a little easier way if it's already mounted on the machine, is to use this access port and do it while it's on the machine. It's a little easier to see with everything off, and that's why we did it that way. So what we'll do is come in here and take this plate off. Like I said, this is an access plate. And then a little difficult to see in here, but then you can access the flag nut in there, and you can see as I spin, you can access the socket head cap screws, get to either one of those. And of course you have to get the jam nut behind the flag nut, and that is where the punch pin or some type of pin would be able to use to hold that in there, and then you can turn the front of the spindle to break that jam nut loose. Like I said, it's a lot easier to do with everything off, but certainly understand if it's on the machine, this can be done. Again, minor adjustments only. One complete revolution is 1.5 millimeters, so you definitely want to make fine adjustments on this. And your ejection stroke range is between 1 millimeter to 1.6 millimeters. So again, if you go one full revolution, that's about the whole stroke you would want. So this should be set from the factory, and you shouldn't need to adjust too much. I just want to point out, again, depending on the year model of your unit, you could have different flag nuts. They all serve the same purpose. This one is a 2-piece flag nut. It goes together like this. You still have 2 socket head cap screws here that using the pinch clamp to clamp the unit. And then sometimes you do have a set screw, so definitely want to make sure that's out and free. So the unit should rotate fairly easily once everything's loosened up. So I hope you found all this helpful. Please follow us on LinkedIn, join us on Facebook for all the latest news from SUHNER. Thank you, hope to see you soon.